So thank you, everyone, to be here. Yeah, I already been introduced. So I'm used to work in the space between spatial computing and artificial intelligence in Amazon Web Services. I don't know how many of you know Amazon Web Services. Raise your hand. Someone? OK. You're already using services from our platform. Are you familiar with that? Or? Yeah, OK, someone. Hold this. OK, so the idea today is showing you the result of some discussion I got with a customer last year and a half in the space of digital human. And I will try to give you some advice and state of the art and building blocks and utilities we have built for creating this kind of use cases in order to not starting from scratch if you want to build a digital human. So first of all, what's a digital human? You probably know, but there can be some confusion around. But digital human, it's a AI-powered, human-like virtual being. It's a definition, very easy. And it's composed by two main elements. So one is the aspect, so the fact that it's human-like. So not really an avatar, not really a I don't know, robot or a virtual character. It's a human-like virtual being, so something very similar and close to a real person, plus the intelligence, because sometimes we need intelligence with human beings. So the use cases, of course, there are a lot of use cases for avatars and other scenarios, but in particular for the digital humans, there are specific use cases where you want to have a very human-like digital human, so avatar, and can be brand identity, so brand ambassador, where I don't know, in fashion sector, they really need a very close look-alike human being ambassador, as well as in customer care. If you think about healthcare, for example, the empathy that you need to connect with your customer is strong, and having a human being that is very close to a real person is crucial for some kind of scenarios. And also teaching, in particular, if you want to teach to child, sometimes it's better to have in front a real person that is more credible than for child. Sometimes for standard training, it's better to have in front a digital human. So the main challenges for that, I mean, what you find to define this kind of use cases normally can be grouped to performance and quality. So in performance, you have to consider that it must be real time. So we are already in the metaverse here, so we need to have a real-time interaction with a digital human. So having real-time interaction, real-time rendering for interaction, lip sync, for example, it's something crucial, in particular when you are in a real-time scenario, and also the quality of animation, of rendering, and most of all, of the intelligence of the human being that you're in front. Today, I will focus on an example on how to build that on MetaHuman. Mind that we have partners as Amazon Web Services that can build this kind of, already have a platform for building easily and integrate the service of intelligence. So the artificial intelligence services I'm going to show you can be already integrated in these partner platforms. But let's try to build, so go for the most complex solution. So first of all, the rendering part, the MetaHuman platform helps a lot for the rendering and design. So let's have a focus on the intelligence part. So in the machine learning platform in Amazon Web Services, we have already planned a lot of different services. I don't want to spend that much time here, but all the AI services you see here on the top of this schema are the service that we call the managed service for artificial intelligence. So our service where we already provide a training model for artificial intelligence, and there is chatbots, there is voices services in the core of AI service, and also there is vision And we will take a look at this kind of service. And those are very easy to integrate. So you can, as I call a REST API, they already managed to scale, already optimized for having the best performances. And we continue to improve the quality of the services. So it's really out of the box, you can connect these services. So the first step in creating an intelligence for digital human is the voice generation. So how we can create the voice. Here we have Amazon Polly. Amazon Polly, it's a full managed service in the space of the AI services we have. It's a text-to-speech service, fully managed. So you pass a text and you get a couple of things. First of all, the audio, so the translation in audio of the voice, plus some marks that we'll use for our digital human. It's the service that is also used for Alexa, if you know the service. So kind of, it's fully API-driven. It's built in different, let me say, flavor. So there is a concatenative set of standard voices in different languages. Plus, we have this neural text-to-speech solution. I will give you an example in a moment for that. And also some, let me say, classification, so like newscaster and conversational styles, styles of voice. So we build specific model for newscaster and conversational styles, so kind of slang. And we can easily integrate this service in our solution. So about the neural, I don't want to spend that much time, but the difference between the standard and the neural text-to-speech is normally in the standard version, it's every single word it's generated and then concatenate. So sometimes can be a little bit robotic in the conversation. The neural text-to-speech is using deep neural network, and it's more sophisticated in the generation. And also on top of neural, we have the newscaster and other classification. So if the sound works, this is the standard one.
Sources tell CNN he believes the media and the Northeast elite are needlessly hyperventilating and overreacting to his comments.
The neural one.
Sources tell CNN he believes the media and the Northeast elite are needlessly hyperventilating and overreacting to his comments.
There is difference. Have you heard differences a little bit? And the newscaster one.
Sources tell CNN he believes the media and the Northeast elite are needlessly hyperventilating and overreacting to his comments.
Okay. And then there is other voice. So
President Donald Trump said on March 13 his administration was ordering the grounding of all MAX 8 and 9 models, hours after Canada said it was grounding the planes after analyzing new satellite tracking data.
I jumped to the newscaster. It's still a bit.
President Donald Trump said on March 13 his administration was ordering the grounding of all MAX 8 and 9 models, hours after Canada said it was grounding the planes after analyzing new satellite tracking data.
Okay, there is difference, right? So imagine your digital human that can use this voice for newscaster for the news. It's something, a scenario that's very easily buildable using MetaHuman plus Polly with this neural voice. We also have brand voices. So we provide as a service brand voices. So we can customize a voice for your specific digital human identity. So we see the ambassadors. So ambassador is not just a lookalike, but also the voice. It's part of the aspect of an ambassador. So we have, for example, we work with KFC.
Hi,
in Canada.
I'm Colonel Sanders, the founder of Kentucky Fried Chicken. Let me tell you a joke. What do you call a chicken crossing the road? Poultry in motion. Got it?
Okay.
Poultry in motion.
Okay.
Food for laughter.
Okay. But yeah, that's an example. So we work in Canada with Kentucky Fried Chicken. And that's an example on a brand voice we can generate. But the most important aspect about Polly is the speech marks. So Another API, so it's a distinct API from the one that generates the voice, can provide the speech mark for the lip sync, mainly. So providing the synchronization between facial expression, animation, and the voice. And mainly, it provide Bazims. This is an example from human. So the position of the mouth for each value of this one with the right time, where you see the time, it's the timestamp in which this particular Basim is reported and must be used for the lip sync. And based on that, we have built a sample. I will provide you the QR code in a couple of slides, so read you with a mobile phone if you want. This is on GitHub, it's for free. Mainly we generate a project connecting MetaHuman and Polly. And in this project, you will find a speech actor component, so a component that can already call the Polly API for the sync with the voice. And can be added to any MetaHuman. You can create your own MetaHuman, bring to the project, and add the voice, this speech component to your MetaHuman. As well as we have created an animation blueprint. So it's already in the project. You can see here, it's probably not super visible, but there's the Basim here as variable. So there is a full map of all the mouth position and animation for the lip sync through using Polly. And this is the result. Let's see if it starts.
I'm Ada and I'm a metahuman. I can say custom phrases, just enter some text and press the speak button to get me to recite it.
And this is
Be
real
aware
time.
that I always finish my speeches, so just relax, dude. This is a test phrase to show it's in real time.
Of course, it's a video recording, but it's a sample of a real time. So you just ingest the text, and it's been generated by Polly in real time, and also the lip sync is generated in real time because of this project. And here, if you want to grab the QR code for the project, this is a sample and can be extended. 3 seconds for the QR code. Okay, and this is the architecture that we have. It's quite simple. So it's just the engine we have. So the MetaHuman project can be deployed on the cloud. Of course, you can leverage on the rendering in the cloud for the MetaHuman, calling Polly and providing the voice as you have seen. But what's the next step? So the voice interaction. So in this case, Polly is just generating the voice. We have plenty of different flavors for neural voice, brand voice, and a lip sync, but we need to interact with the digital human, right? So for that, we have another service. It's called Amazon Lex. It's our conversational AI. It's a service that builds conversational interface for applications, so using voice and text. So you can use both. And it's connected, for example, with Lambda. So if you had an experience with Alexa, also Up is similar. So it's kind of the engine, an engine similar to the Alexa one for building, the utterance and the flow of the conversation. It can be connected to the backend through a Lambda, for example. And so we can use this service for, in general, it can be used even for just customer care. In call center, we have our offering here. I don't want to spend much time, but it's connected with other service. Of course, we can use that in our digital human shape. And one of the customer, it's not really a digital human. It's a robot, but it's a similar. So it's a project. Roiba it's a robot for children, for education. I'd use Polly, Lex, and what we'll see in a couple of seconds, also recognition, so the computer vision part, providing interaction with the child. So if we want to extend our architecture, we can add Lex. So the idea is in the speech component, you can integrate Lex. Lex can manage the conversation, and through a Lambda can generate the voice through Polly and use the same project for limp sync, so what's already available on GitHub, having the conversation that can be using voice and using the text. One missing part in the project, there is also already the SDK compiled for Poly on GitHub. So we provide, of course, SDK for different languages. In this case, it's C++ because of Unreal Engine. But now I would like to introduce a kind of discussion so this is the state of the art until now. So voice, conversation, digital human. In last year, I had some conversation, many conversation with customer. They want to make a step forward, an evolution in the empathy of the digital human. And one idea, not because I'm a specialist in computer vision, but I was interested in that. So one suggestion I gave is using computer vision for that. How we can use computer vision in a space of digital human. If you think about a digital human, have an intelligence for speech, but it doesn't see you. So if we can add the vision to the digital human, we can create additional scenario. So for example, the digital human can recognize you using face recognition. So can know who is in front without asking. Can understand your sentiments based on your face, not speech, not word, not text, just looking at your face. Maybe you are confused, imagine in a healthcare scenario or for a child, understanding if the person is confused or fear or is happy, and also the attention. So how we can measure if a child is not looking at the teacher, for example, is looking, I don't know, at this mobile phone or other stuff, is not following the training. We have another service here. It's called Amazon Recognition. It's part of the AI Vision service. And we can implement these 3 use cases I mentioned before just with models that are already provided. So for example, it's a set of different computer vision models. Okay, I don't go to explain every computer vision models there, but for our use cases, we can use face recognition. There are 2 flavor. Even here, there is face comparison, so matching 2 pictures. If you already have in your application the face of the person that you want to recognize and just match if it's that one, because it's already a kind of 2-step identification to understand if it's the right person or not. Or we have a service in an API in recognition for face search. So you can have your cluster of all the faces, and your digital human can understand who is in front of him by looking at his face. And it's just an API. You just provide one image, and it's done. So it's super effective, and you get all the computer vision bandwidth for free. Another service we can leverage on is the face analysis. It's called face analysis in the API if you're looking for that. Of course, it runs also a computer vision model for face detection. So it provides where there is a face and some elements. Those are some of the elements that are provided by the API. API, of course, return JSON. And by using some of this information, we can, for example, understand the emotion. So it's return the emotion based if happy, there's also confused, and another emotion that can be evaluated by the service. And so the digital human can change its conversation flow based on the emotion. And also we have facial landmarks. So we can understand where are the eyes and also the left, right bubbles. So you can understand even if the person is in front of the camera, if it's looking on the right or is distracted for some reason. And also the facial pose. So if the head is rotated, maybe it's looking not in the direction of the avatar. So using these elements, you can integrate the solution and having the final implementation on those. So having a person in front of a camera, of course, in your application can be a mobile phone or a camera on laptop or I don't know a stand or whatever, where there is your digital human and the application, by grabbing some frames, sending the frames on S3 and Lambda. Lambda can integrate recognition, store the information. Normally, best practice is store some information on the, particularly on the motion, just to then compare and trying to see, I don't know, if in a range of 30 seconds, the most prominent sentiment is confusion. You can try to adapt. And so adapt your conversation flow. And so Lex mainly is also through the Lambda backend is also going to grab this information on the computer vision part, understanding who's in front of the camera and I don't know, the sentiment in the last 30 seconds. Of course, you can configure that as you want. And then using Polly back for the lip sync and conversation for the meta-human. I think that's all. They asked me to have 5 minutes for questions. There are 4, so
Perfect
I'm on time.
timing,
Perfect
well
time.
done. Round of applause for our speaker, please.
Thank you.
Thank you very much. That was fascinating.
Oh.
The hand shot up straight away, so sir, please go ahead. And by the way, just very quickly, for the sake of the recording, I'm going to reiterate what you say, so I'd really appreciate if you kept it relatively short.
Two questions. On the sentiment analysis, do you do that without any training at all? So my face looks a little different than your face. And then also, what's the business model? Like pay per usage for API call?
So there is an API in recognition. Oh, sorry, you have to.
Do you want to reiterate the question?
No, please. No.
So what's the business model was the second question, and the first question was, I've forgotten.
How to train the model for face recognition.
Was there any training data at all, or was it just done raw?
So those are, I give the response for the second first. So all the API you see, there are pay-per-use, so you just pay for the API. There is no subscription, no license. So you just open an account on AWS, connect the API, you pay per call. So that's the business model. About how to train the recognition is just by providing one single image to an API that is within recognition. It's called face collection. So you can index one face just providing an image. We extract the feature of the face, so and we just store a vector, so not the picture. Even for GDPR, another problem that can occur on that. So we just store the vector, and then we merely index this, and you can search the face by providing another image. We extract the features, and we compare the features for the search. So that's how it works, more or less. And it can really scale to up to millions of faces in one single collection.
Any other questions?
So
Give me a sec.
oh, sorry.
Are there any offline versions of this service in case you'd have internet connection issues?
Yeah, no, may occur. So the AI services, most of them are in cloud, so are for the model. In the middle of the layer that we are showing, the machine learning part, there is a SageMaker. And in this part, you can build your model. There are pre-built models where you can train your model. Of course, you can use on the edge. But not all the service I show. I mean, Polly is just providing you a file, but it's for real time, of course. It's not working. Even if you unplug Alexa, that's it doesn't work.
There was another hand that shot up somewhere over there.
Hi, I'm just wondering, because the use cases you shown were based on Unreal MetaHuman.
Yep.
Plans to expand the support for Unity, the Unity engine, I mean?
Any plans to expand from Unreal to Unity?
We have an SDK plugin for that, so we don't have all the mapping, the speech component, etc. But it's a good point. I take the point for. I mean, we're supporting Unity, of course. So our vision is to support all these engines because we don't have our own engine. So yeah, a real Unity, 3JS, Babylon for WebXR. It's all our own now scope. So.
I think we've got time for one more. Does anyone have a question? Here we go.
What about adaptive gesturing? Do you have a solution for that?
Solution for adaptive gesturing.
There is some gestures already in the package. I didn't show that. So for if you remember the video, there is a gesture with the hand. So it's part of the package. So it's randomly adapting through so not super accurate with the voice, but you can build, of course. You can extend the plugin. It's open. So it's on GitHub. It's open.
Perfect. I'm going to steal the last question, if that's okay, even though we've run out of time. That'll be all right. So I had an experience once whereby I was in VR headset, having an interaction with a friend in a different city, we were playing mini golf, and it was, it was producing emotions in my avatar on behalf of, on the basis of my speech. So it was passing the prosody of my voice. And I was telling a story about, we've been mates for a long time, since university. I'd had a falling out with a friend that I've been really great mates with for 20 years. But I was talking about how upset I was in the past tense. And I was saying, it's just been a terrible first couple of months this summer. I've been to hell and back. I've been awake, worrying about it at night. And my face was expressing these profoundly sad emotions. And he was like, are you all right? I thought you were saying, like, that this is in the past and that you're over it now and you're feeling much better because you finally found a resolution. But, so presumably you did the facial recognition aspect of it because voice alone is not enough to convey emotions.
Well, it's the opposite probably. So we have a service called Amazon Comprehend for analyze the voice, understand the sentiment from the voice. So it's a transcription.
It wasn't the prosody, it would be the
getting
language.
The emotion and then translate with an animation or, I don't know, a smile, whatever.
But it was really interesting that my emotions were being fundamentally misrepresented in the moment because it wasn't a completely finished product. You know what I mean? They kind of like scrabbled it together, and if it seen my facial expressions, it wouldn't have seen any sadness on my face because I kind of processed it.
Yeah.
So anyway, I just thought I'd share. One last round of applause for Woody. Excellent talk.
Thank you very much.
Thank you.
Thank you, everyone.